This screencast talks about how to identify significant figures in a measurement. The numbers reported in a measurement are limited by the measuring tool. If I have a meter stick, it can only really measure 2 millimeters, and then I can make a little estimated digit after a millimeter. Significant figures in a measurement include the known digits plus one estimated digit. We're going to learn to identify these significant figures and then how to apply them in calculations so that you always know where to round to. This prevents numbers from ended up being more exact than the actual measurement. So, there are only 4 rules. The first rule is that all non-zero digits are significant. So, if it is, the only ones we have to really worry about are zeros. If we look at our examples here, in this number, 38.15 centimeters, there are 4 significant figures. In 5.6 feet, there are 2 significant figures. In this number, there are 3 significant figures. Oops. And in this number, there are 5 significant figures. Rule number 2. Leading zeros in decimal numbers are not significant. They're basically placeholders. So if we have a number like this, and you know from math class you don't even have to write this 0, it's just telling you that a decimal is coming up. The leading zeros, the zeros that come before the first non-zero digit, are never significant, so this measurement only has 1 sig fig. In this number, again, leading zeros are not significant, so this number has 3 sig figs. This number has 2 sig figs, and this number here, which is very small, has 3 sig figs. Rule number 3 involves sandwich zeros. Zeros between non-zero numbers are significant. So, if you have a 0 between non-zero digits, they are considered significant. So this number has 3 sig figs. You can see from this example, it doesn't matter how many zeros there are in between, as long as they are bookended by non-zero digits, then they are considered significant. So this number has 4 significant figures. This number only has 3. This 0 is a leading 0, so now we're starting to combine the rules. So it is never significant, but this 0 is significant because it's in between the 7 and the 2. In this number, our leading zeros are not significant, but this 0 is significant because it's in between 2 non-zero digits, so this number has 3 sig figs. Our last rule tends to be the trickiest, and it has to deal with a decimal and trailing zeros. So these are zeros at the end of a number. Trailing zeros in numbers without decimals are not significant, but trailing zeros in numbers with decimals are significant. So it's kind of a double whammy, and you kind of have to look at that one. This one, like I said, is the trickiest one, but with a little bit of practice, we'll have no problem. So in this number, 25,000 inches. This number only has 2 sig figs. These trailing zeros are not significant because there's not a decimal anywhere in the number. So really this measurement is saying, about 25,000 inches. Not exactly, because that's what the decimal would tell us. So only 2 sig figs in this one. In this number, we have 200 decimal point. That decimal means that we measured this out, and it is 200 years decimal point. So trailing zeros in numbers with a decimal are significant. So there are 3 sig figs in this number. This number right here, we have 3 non-zero digits, and then these trailing zeros are not significant because there's not a decimal anywhere in the number. So this one only has 3 sig figs. We're saying it's about 48,600 gallons, but I didn't measure it out too much further. We have a same situation here. Again, no decimal in the number, so our trailing zeros are not significant. These zeros are significant because they are sandwiched by these 5s. So we have 5 sig figs in this one. So let's practice identifying sig figs. This number has 3 sig figs. This number also has 3 sig figs. Take a look at this number. It has 5 sig figs. These zeros are significant because they are sandwich zeros. In numbers in scientific notation, don't worry about the times 10 to the whatever power. Just look at this number. In this particular number, we have trailing zeros. They're at the end of the number. There is a decimal here, so that means it is 9.8000. I measured it out that far. So these are significant because of the presence of that decimal point. So this has 5 sig figs. Again, we're dealing with trailing zeros. As long as there's a decimal anywhere in the number, trailing zeros are always significant. So this one also has 5 sig figs. This one has 2 sig figs. It's easy. It doesn't have any zeros. All the rules combined in this one. See what you can guess. This one has 4 sig figs. These 2 zeros are not significant because they're leading zeros. This 0 is significant because it's sandwiched by the 7 and the 8. And this 0 is a trailing 0 in a number with a decimal, so it is significant. And these are our 4 significant figures. This number, again, deals with trailing zeros, but there's not a decimal anywhere in the number, so there are only 2 sig figs.